Hello, class. Welcome. We are going to finish up our unit on aerobic acute factors as it relates to aerobic exercise. So again, we finished this slide up in class, but here we're taking a look at some of the acute neural changes associated with aerobic exercise. So again, we talked about how the cerebellum contains all these different plans, and so within the cerebellum, we can pull out these plans and be able to utilize those um, based on the activity that we're doing. And again, this is one of the reasons why when we do a warm-up, it's important that we kind of mimic some of the movements that we want to do when we compete so that we can pull out those appropriate plans so that they're kind of ready to go. Okay. Cerebral cortex, so we're going to use kind of higher order thinking in order for us to be able to modify and fine tune those plans. So for example, if I was a tennis player and I have, my automatic plan for my serve and I have that ready to go, well, what if it's a windy day? Or what if it's rainy or something along those lines? So I need to be able to fine tune that plan depending on the environmental conditions. So we're able to do that through the use of the cerebral cortex. As it relates to acute muscular changes, we're going to have selective activation and recruitment of the appropriate motor units. Again, a motor unit involves a alpha motor neuron and all the muscle cells that it innervates, and the appropriate motor units that we want to use when we do aerobic exercise will be type 1 fibers. So those slow twitch fibers, we want to activate those slow twitch motor units. So we'll have selective activation or recruitment of those cells. Okay, so we want to activate those slow twitch fibers. We're going to also have enhanced metabolism within the appropriate muscle fibers. So kind of the cool thing, let's see if I can do a little drawing here for you. The cool thing when we think about muscle, this isn't going to be a very good drawing. So again, if this is the muscle and imagine that I have like, 30 little cells in here, okay? When I do aerobic exercise, I'm going to activate like 50% of those. So let's say I activate like 10 of those cells, those slow twitch fibers, and I'm able to increase metabolism of whichever ones we're using, okay? So those other cells might look like they're resting in comparison to those type 1 fibers, those slow twitch fibers that we're using during the activity. Okay. We'll also see an increase in temperature at the level of the muscle. This will enhance contractile force, speed of contraction, and clearance of the waste products. So that's freaking cool. So as metabolism increases, as you know, one of the byproducts of metabolism will be heat production. Well, as the temperature in the muscle increases, this actually enhances our ability to do work, which is again another selling point for us in terms of why it's important for us to do a diligent warm-up so that we can increase our temperature and increase the contractile force of these muscles, increase speed of contraction so that we can do things with power as well. And next thing we want to look at are the acute hormonal factors associated with aerobic exercise. So we're going to see hormonal changes again. We've already talked about these when we did our metabolism unit, but now we want to think about these kind of as more of an all-encompassing role as it relates to the aerobic exercise bout. So we said that epinephrine and norepinephrine were going to be important as it relates to the sympathetic nervous system. So these are like our adrenaline. And so when these are released, they're going to kind of have an all-encompassing effect on the body. They're going to increase heart rate. They're going to increase stroke volume. They're going to increase vasodilation of the arteries that lead to the muscles. They're going to vasoconstrict to the arteries that lead to the gut. They're going to cause bronchodilation in the respiratory tubes. So they're going to do all these different things to help us be more efficient during the exercise bout. And I guess the end goal or the end takeaway from this is they're really all encompassing. They're going to have an effect on the entire body. Okay. The next hormone that we want to take a look at is ADH, which means antidiuretic hormone. And this hormone is responsible for water retention. So if something is a diuretic, that means it makes you pee. And so an antidiuretic is going to help you to retain water. So it's going to help you to prevent water loss through kidney filtration. So we're going to hold on to those fluids, which is good during exercise because I'm sweating, so I'm losing fluids in other ways. So I don't want to also be peeing out fluids. So I'm going to get rid of some fluids via sweat and also respiration. When you breathe out, you're breathing out some or some water molecules. So we want to kind of minimize the work of the kidneys at this point so that we can hold on to or retain water. Okay. Cortisol we talked about. So cortisol is a hormone that's important for inflammation. It also affects metabolism, so it's going to allow us to increase the availability of both sugars and fats so that we have those available in the bloodstream so that we can utilize them. Can also help us in the recovery process as well. Growth hormone, also important during acute exercise. Again, this would allow us to kind of enhance that recovery process after the exercise is over. Okay, so when we think about how these hormones are changing during acute exercise bout, epinephrine, norepinephrine, ADH, cortisol, growth hormone are all going to increase. Okay, insulin is going to decrease, and again, we talked about this as it relates to metabolism. So the decrease in insulin means that we are not going to be storing sugars at this point, which is good. We don't want to put things into storage and also take things out of storage. So as a result, because we're going to be utilizing sugars, we want to not be inefficient with our time, right? We don't want to be putting things into storage and then also getting them out. Okay, so insulin will be turned off, which means we're not going to be storing sugars at this time. Okay, so let's talk about Vo2max. Again, to kind of give us a general definition of this, and again, kind of one of the major purposes of this PowerPoint is to prepare you to understand the purpose of the lab that you're doing, so this aerobic performance lab that you're doing, and also a lot of this information will be really important for you, or hopefully very helpful for you as you're working on your lab reports. Okay, so Vo2max represents the amount of oxygen consumed. VO2 represents the amount of oxygen consumed or utilized at a given time, and usually it's per minute. Okay. Vo2max represents the maximal amount of oxygen that can be consumed and utilized. And again, it's usually in terms of per minute. It can also be stated based on your weight as well. So usually Vo2max label is ml or milliliters per kg per kilogram body weight per minute. Okay, so we're looking at the amount of oxygen based on your body weight that you are able to bring in per minute. Okay, not only do you need to bring it in, but you also have to use it. Okay, so we're looking at the amount that you've actually utilized. So we can measure VO2 at a resting level. You can measure it at submaximal levels, and that information can be important to us in a variety of ways. Again, with Lab 2, we used indirect calorimetry to measure your VO2 at rest, which allowed us to calculate or estimate your resting metabolic rate. Okay. When we measure Vo2max, we're less concerned with metabolic rate. We're more concerned with maximal exercise capacity. Okay. So very complicated in terms of what all has to go right in order for us to utilize the oxygen. So first thing we want to do is we got to bring the air into the lungs. Okay. So as we inhale, we want the air to travel down to the alveoli, which is our most terminal unit of the lungs. And this is where exchange will occur. So moving on to number 2, we're going to have exchange of oxygen from the alveoli into the blood. And this is known as external respiration. So again, external respiration is not breathing in and out. External respiration is the movement of oxygen from the lungs into the blood. Okay. After we get the oxygen into the blood, we're going to carry the oxygen to the skeletal muscle. So it will be transported in the blood, bound to hemoglobin most likely. And then once it reaches the skeletal muscle, we need to move our oxygen from the blood into the skeletal muscle. And this process is called internal respiration, which is kind of crazy if you think about it, because internal respiration, you think about respiration and breathing, but internal respiration doesn't have anything to do, really, with breathing at all. It's several steps down the road. So we're looking at our ability to move oxygen from the blood into the tissue so we can utilize it. That's internal respiration.
So then once we get the oxygen inside of the cell, we're going to move it to the mitochondria of the cell because that's where aerobic metabolism occurs. Then we will utilize oxygen in the electron transport chain to create ATP. And this is known as aerobic metabolism. Okay, so in terms of testing for Vo2max or estimating for Vo2max, probably our best bet is to test Vo2max on a treadmill via what's called indirect calorimetry, okay, through the use of a metabolic cart. So again, all of you met with me and learned how to use our metabolic cart. And again, the idea with indirect calorimetry is we can tell how much oxygen you've used. So we know what the oxygen concentration is in the air, and then we look at the amount of oxygen that you exhale, and basically that allows us to calculate how much oxygen you've utilized. Okay? So that's basically what a VO2max test is doing, is looking at how much oxygen you've actually consumed via this metabolic cart. Generally speaking, a Vo2max test is graded and incremental in nature. So basically what this means is with graded, it's going to start easy and it's going to get harder and harder each stage. And with a Vo2max test, you want to go as far as you possibly can if you want to get an accurate test or an accurate reading. Again, the level of effort that you put into your test is completely up to you. But if you wanted to get a good understanding of what your actual aerobic fitness level is, then you should go as hard as you can. That's the graded portion. The second portion is incremental. So it's going to change at various stages. So each increment or interval is a set amount of time. Usually increments are 3 to 4 minutes in duration. I'm pretty sure that's important. Make sure you write that down. I think it's on the quiz. So usually increments are 3 to 4 minutes in duration. And the reason for this is we want those increments to be about 3 minutes because that's how long it takes our body to kind of adjust to that stage. So this allows our body to get close to reaching a steady state before we increase the intensity. Okay? The only time this is not necessarily true is when we're doing a stress test. And during a stress test, the increments may be only 1 minute long. And again, the reason for that is we're less concerned with Vo2max when we're doing a stress test. We're more concerned with placing stress on the heart so we can look to see how the heart actually responds to exercise intensity. So multiple submaximal and maximal exercise tests have been developed to estimate our Vo2max values. So again, in this class, you're doing the McConnell protocol on the treadmill to test our Vo2max. And again, that's the test that we're going to be using indirect calorimetry in the metabolic cart. You're also going to estimate Vo2max with a 3-minute step test. And you're also going to estimate Vo2max with a 12-minute walk run. So let's first look at some of the Vo2max testing protocols. The 3 most common are the Bruce Treadmill protocol, the McConnell Treadmill protocol, and the Cycle Ergometer protocol. Okay. The highest Vo2max readings can probably be seen with the McConnell Treadmill protocol. This protocol is designed for athletes or fit people. That's why we're using this in our class. The Bruce protocol is much more common or well known in the world, and the reason for that is it serves as a diagnostic tool. It's great for sedentary people, or it's more appropriate for sedentary people in comparison to the McConnell. It's less stressful because the incline changes are significantly greater, so you actually do less running with the Bruce treadmill protocol in comparison to the McConnell. If you as a fit athlete in this class were to do both, I would guess I would put money on that the McConnell protocol would give you a higher reading in comparison to the Bruce. Cycle ergometer protocol, so instead of using a treadmill, we can do a graded incremental test on a bike of some sort, and again, we'll talk about that in more detail here in a second. Okay, so let's look at the differences and similarities with the McConnell and the Bruce protocol. Okay, so let's start. I've got 7 stages here for both tests. They can go longer than that. That's just what I could fit on this PowerPoint. But again, they're both incremental in nature. They are both graded in nature. The Bruce is 3 minutes per stage. Again, we said the normal increments are anywhere from 3 to 4 minutes. That is no exception with this protocol. McConnell, you get 1 minute in your first stage, and then all the rest are 3 minutes. Again, this first minute kind of, I guess, allows your subject to kind of get acclimatized to using the treadmill, to wearing the Vo2max test, to make sure everything with your equipment is working great before they really get into the test. Let's next look at the grade. So with McConnell, we are at 0% grade until we're up to like 16 minutes. Okay. With Bruce, you're at 10% grade right off the bat. That's a significant amount of grade. And with Bruce, we continue to increase this incline significantly throughout the test. If you are an athlete and you were to do the Bruce protocol, you would probably, I for sure have felt sore in my shins because this is like climbing a mountain with the Bruce protocol. Again, not set up great for athletes. It's better for sedentary people because it will allow you to work at a high intensity without actually running. So it's a little less stressful on your joints, I guess, but it certainly will make your shins sore if you get to some of those later stages. Okay? With McConnell, we don't get to a grade actually until we're at 16 minutes into the test. Let's take a look at our speeds as well. So again, both the graded portion of these protocols are going to involve increasing the actual grade of the treadmill, and we're going to continue to incrementally increase the speed as well. So with Bruce, we start at 1.7 miles per hour. That's super slow. Okay. I would say your normal speed, like walking to and from class and that sort of thing, is like between 2.5 to 3 miles per hour. If you were like a fast speed walker, you would be able to walk at like 3.7 or 4 miles per hour. So again, this gives you an idea, like you can probably walk these first 4 stages with Bruce, and then, when you reach 5 miles per hour, that's probably when you're going to have to start running, probably. With McConnell, you're running almost right away. Again, 5 miles per hour, you're probably running. If not, you're running at the second stage once you get to 6 miles per hour. So, again, McConnell is more set up for an athlete, where Bruce is set up more for a sedentary type of person. Okay, both of them are fairly accurate. But again, for an athletic population, the McConnell protocol seems to be a better fit. Bruce is used more commonly as a diagnostic technique for us with stress tests. Okay. Criteria for reaching our Vo2max: we should have a plateau in VO2 despite a continued increase in workload. And this basically tells us that you are now utilizing anaerobic fuel to continue to increase your workload. Okay, so that's one thing we would like to see in order to actually reach your true max. We would also like your heart rate to be greater than 95% of your age predicted max. We would like our RER to be over 1.1. Again, we know that this means that we're getting an anaerobic contribution if we're above 1.0. So 1.1 is a significant contribution from our anaerobic systems. And RPE is 10. So on a scale of 1 to 10, how hard are you working? 10 being the hardest that you can work. Okay, my perception is that I'm at my max. So we would usually in real true science, the first three are much more important than RPE. We don't really care about RPE because it's not scientific in nature. It's just your perception. So it's really just your opinion. So in a true scientific study, we would want to meet two of the first three criteria in order to actually be considered a VO2max. Again, the idea with this is you've got to get a subject, as a researcher, you've got to get your subject to go as far as they possibly can, get them to 10, and then make them go one level further. So you got to push them to go even further than they think they can go in order to really get them to their true max. So we want to continue exercise until they cannot take another step, and this is known as volitional fatigue. Okay. So who cares about VO2max? Why are we doing this? What is this important for? Our VO2max tests allow us to measure the maximal rate of oxygen consumption and hence really the efficiency of both the cardiovascular system, our respiratory system, and our muscular systems to an extent. Certainly when we say muscular system, we're talking about some of that slow twitch and coordination factors that will be important for us. VO2max test is considered the best non-invasive measure of cardiorespiratory fitness, and it's also considered a somewhat decent predictor of endurance performance, although there are certainly many other factors that go into endurance performance. VO2max will play an important role. It's also useful for exercise prescription. So I might do a VO2max test to kind of understand where someone is and then be able to base their workouts off of where they are from a fitness standpoint. It's nice for us to be able to compare ourselves to standards. So we can use VO2max, and this is one thing that you'll do in this class. You'll measure your VO2max and then look at a chart to see kind of where you fall based on your age and gender in terms of what are the norms, what are the standards. It also can allow us to see progress within an exercise program. So maybe I'm your personal trainer. I might do your VO2max test when you start working with me. And then, a few months down the road, I want to test your VO2max again to see how you've progressed within the exercise program. And then I can say, wow, well, this program worked really great. We saw a 10% increase in your fitness level. So it could certainly play an important role for us in terms of understanding what is an efficient exercise program. So from a programming standpoint, it can be super important for us. Also, that's super cool, I think, too. So I love to see if I'm improving or not. So this can be a great benchmark for us in terms of, oh, I am getting better. I am getting faster. I am getting, more fit in nature. So it's a great tool for us to see progress within an exercise program. Probably the most important reason that we're going to do a VO2max test is for a stress test. And a stress test is basically like they hook you up, sometimes with the VO2max, sometimes without. They are also going to hook you up to an EKG so we can see the electrical movement within the heart. And we're going to put you on a treadmill and have you do an incremental graded exercise test in order for us to see how your heart responds to stress. So exercise physiologists would use this in a clinical setting in order for us to determine or to diagnose various cardiovascular issues or disease when under stress. So again, that's probably the most common time we actually use VO2max tests, but we can certainly use it as a measure of our fitness level for exercise prescription or to see progress within an exercise program. So what factors are going to influence our VO2max? So make sure you pause this throughout and get all of these numbers down as I run through this information. So heredity can account for 25 to 50% of your VO2max. Gender, so males generally have 15 to 20% higher VO2max levels in comparison to our females. Age, So it appears that the peak for Vo2max is somewhere between the age of 18 and 30. I would postulate that this is highly related to how much you're doing. So, maybe you peak at the age of 18 because that's when you really stop doing a whole lot of physical activity. Maybe you're able to peak when you're 30 because you continue a vigorous exercise program and so on. So it seems like somewhere between 18 and 30 is the appropriate age for our Vo2max peaks. We're going to have about an 8% decrease in Vo2max per decade after the age of 30. Okay, so from 30 to 40, you're going to have an 8% decrease. From 40 to 50, you're going to have an 8% decrease, and so on. But it does appear that there's a light at the end of the tunnel here. It does appear that these changes or these decreases can be counteracted and maintained somewhat with regular aerobic exercise. So if you can continue to train at a vigorous level, you should be able to maintain these fitness levels and kind of delineate some of these decreases. Training status, how hard you're working, how hard you're training can certainly account for a huge change or a huge improvement in your Vo2max. 6 to 25% improvement with training. So that can play a huge role for you. And also the mode. So we talked about a cycle ergometer test versus a treadmill test. It seems like biking, you'll get about a 10% lower reading in comparison to a treadmill for a regular person. It depends more highly upon your training status within that mode. So an elite cyclist would be able to probably get a higher Vo2max reading while biking in comparison to on a treadmill. However, a runner would probably have a substantially higher Vo2max, probably maybe like 20% greater, while running in comparison to while on a bike. So it certainly depends on your training status, but somebody who's highly trained in biking should be able to get just as high on their Vo2max on the bike in comparison to when they do the test on a treadmill. Submaximal exercise test can also be used as a way to estimate our Vo2max. So while Vo2max testing through the use of indirect calorimetry, so using the treadmill, using the metabolic cart, all those things, is the most accurate way to determine maximal oxygen consumption. Submaximal tests may actually be more practical because they don't require expensive equipment. They can also be shorter or quicker in nature, so you don't have to spend, a whole, if you're a personal trainer, for example, or working, one-on-one with somebody, you don't have to spend the whole session just doing one test. With the submaximal test, you're able to get a fairly decent estimate with the submaximal test, and then you still have plenty of time to do whatever else you need to do for that given day. Also, the equipment is super expensive, so metabolic carts probably range from anywhere from like $4,000 to $50,000, so it's a super expensive piece of equipment. So, it's not always feasible for each lab and every personal trainer and that sort of thing to have these. Certification exams, so like NSCA, and also ACSM and AFAA. I'm trying to think of other organizations that I'm familiar with. Many organizations require the understanding and administration of submaximal tests. So a lot of these certifications place a greater emphasis on submaximal tests because they're much more feasible for everyone in order to complete and also administer. So, determining heart rate response during submaximal exercise allows us to estimate a person's aerobic capacity. A more highly trained person will have a lower heart rate compared to an untrained person. So again, having a low heart rate during these submaximal tests is to our advantage. Many submaximal tests to choose from. So we've got the Queen's College Step Test. That's one that you'll be doing in this lab. Cooper 1.5 mile run walk or the Cooper 12-minute run walk. Same person actually developed these two tests, and he was from Springfield College, actually. And in this class, you'll be doing the 12-minute run, the Cooper 12-minute run walk. Rockport fitness walking test and YMCA bicycle ergometer tests are all submaximal tests that can be completed. So again, I'm not going to spend a whole lot of time or really any more time talking about the Queen's or the Cooper's test because those are two that you'll be completing in this class. But I do want to take a second to talk in a little more detail about the Rockport fitness test, which we will not complete, and the YMCA bicycle ergometer test. So Rockport fitness test is going to assess our Vo2max via a 1 mile walk. Subjects are asked to walk 1 mile as fast as they can. 1 mile time is recorded as well as heart rate at the completion of their walk test. Again, not a great test for athletic population. Certainly is not going to be very accurate for these people. This test is designed for sedentary people, also great for elderly people. Like I said, in terms of accuracy, not extremely accurate for fit individuals. And also keep in mind the accuracy is based on your motivation level. So how hard do you want to work? And also your ability to pace yourself for the mile. Okay? Vo2max values may vary 16 to 20% off. So, and it seems like for fit people, it's 16 to 20% too high from this test. So the Rockport fitness test seems to overestimate Vo2max levels for fit people. Again, it seems a little more accurate for a sedentary or elderly population, so this is not to be used for someone who would be considered a fit person. Okay, the YMCA bicycle ergometer test, again, it's submaximal. We're using some sort of bicycle during this test. The test is incremental in nature, and the subject gets to go to about 75% of their predicted maximal heart rate. So, again, we keep it submaximal, but it is graded and incremental in nature. Subjects ride at a cadence of 50 revolutions per minute, which is actually pretty slow. I normally bike at a cadence of like 78 to 80 is my normal cadence, so 50 is super slow for a cadence, but again, for untrained people, they really want to go slow with the cadence, so this is extremely slow cadence. We're going to measure heart rate and blood pressure every 3 minutes. The test lasts for 12 minutes. Accuracy, it actually tends to underestimate our Vo2max about 10 to 15%. Again, it's submaximal in nature, and with a biking protocol, this is appropriate for many types of populations. And again, a little more accurate than what we saw with the walk. We're down to 10 to 15% as an underestimation with this test. Okay, how do we know when to stop a test? Okay, so several things we should look for, and if these things occur, we need to stop the test immediately, whether it's maximal or submaximal in nature. And again, I want you to keep these in mind when you're testing each other on the treadmill with the Vo2max. So 1, the onset of angina. Number 2, if we see a drop in systolic blood pressure despite an increase in workload. Again, we're not necessarily monitoring blood pressure, but I do have a blood pressure cuff on that cart that had all the other equipment if an emergency were to arise. If you have an excessive rise in blood pressure, such as systolic above 250 or diastolic greater than 115, that's something we should be worried about. Shortness of breath, wheezing, leg cramps, claudication, which is pain in the legs. Those are things to be aware of. Signs of poor perfusion, lightheadedness, confusion, nausea, cold and clammy skin, change in heart rhythm, or subject requests to stop. So these are indications to stop the exercise test. Certainly, we are hoping that the reason that we're stopping our maximal exercise test is because the subject requests to stop. That's really what we're hoping for. But again, these are other things we should be aware of and kind of keep our eyes open for. What are some of our gender differences in aerobic performance? Males, again, tend to be 15 to 20% higher VO2max levels in comparison to females. A few reasons for this. One is testosterone. So men have more testosterone than females, and this causes men to have more hemoglobin, which means they have a higher oxygen carrying capacity within the blood. Men also have more muscle mass, so therefore they require more oxygen compared to females. So that's another factor. They also have greater lung capacity, although this isn't a huge deal because we said the pulmonic system is not necessarily our limiting factor. But, if you have broader shoulders and you're a larger person, you're going to have a greater lung capacity than a female. Okay. So let's have a look at some of the factors that are going to affect our maximal aerobic performance. Certainly diet, again, as we'd mentioned in our last unit, carbohydrate intake is of great importance to us, and also fluid, so our ability to stay hydrated will be important for us. The nervous system function, so arousal and motivation. Arousal level has to do with how we perceive a situation, and so therefore what is our physiological response as a result of that. So a high arousal level can be good for some of us. Some of us get too worked up, so a high arousal level could be bad for others. So it certainly depends on the person in terms of figuring out what the optimal arousal level is. And motivation, like how hard do you want to work? How bad do you want it? How bad do you want to win this race or this game or whatever? Strength and skill certainly play a role in our performance. Natural endowment, unfortunately or fortunately, depending on who you are, there is certainly a genetic component to how well we will perform. Practice. How hard are we working? How skilled are you at that particular activity? Some aerobic exercises require a great amount of technique. Swimming, for example, requires a great amount of technique. So it's really important for us to practice and have appropriate technique for that. Body type, again, probably related to genetics as well, but people with broader shoulders are going to be more likely to be successful at swimming in comparison to people without broad shoulders. So, a body type can certainly set you up for success in certain areas and not set you up for success in other areas. Also, muscle fiber type, again, certainly related to genetics. If I have more slow twitch fibers, I am more likely to be successful as an endurance person. Environment will definitely play a role. Altitude can negatively impact our performance, particularly if we're not accustomed to it. Heat will also have a negative impact on our performance, and humidity will also be negative for us. So heat and humidity are two things I'm ready to face head on Saturday. It's looking like it's going to be 88 degrees, and it's very humid here so far, so I'm looking forward to taking on those environmental factors. Lastly are some of these energy production issues. Anaerobic sources probably play a pretty small role for what we're talking about here. Our aerobic sources, Vo2max, cardiac output, oxygen delivery, oxygen extraction, mitochondria efficiency, and also, that sort of thing will play a role in our performance. So I kind of divided aerobic performance into 3 subcategories. Again, if you remember back to last unit, we said that aerobic exercise is anything 3 minutes or above. That's really a pretty wide range. I would say someone who races in, a 1 mile run versus an Ironman triathlete are going to have some significantly different barriers. So I broke this up into three, I think, a little more specific categories that will kind of allow us to look in a little more detail about what are kind of the major limiting factors for various types of aerobic athletes. Here we go. We're looking at aerobic performance for individuals that are competing for 3 to 20 minutes. So again, a lot of factors that we've already mentioned. Vo2max is going to play a huge role. Okay, let's look at some of the factors that are going to affect that. Maximal cardiac output. Heart rate max we can't control. Stroke volume max we can control. So that can be related to genetics and also training. Okay. Here we're looking at hemoglobin, oxygen intake, how much oxygen do we have, our fiber type, again, genetic in nature there. Mitochondria and capillary density is highly related to training, and so that'll play a role there. So aerobic performance for 3 to 20 minutes, we're very concerned with Vo2max. The ways in which we can improve our Vo2max, guess what? Training. And we'll talk more about training and program design actually coming up in the next unit. Okay. Aerobic performance for individuals that are competing 21 to 60 minutes. Now we're not so concerned with Vo2max. We're concerned with our ability to maintain a VO2 at a given level. So maybe I am able to run at 90% of my VO2 for 60 minutes. Okay. That's more important to me than knowing what my actual Vo2max is. Because if I'm going 21 to 60 minutes, chances are I'm not running or competing at my maximum for the entire duration. Okay. Other things that we should be concerned with, dehydration is going to play an important role. Lactate threshold, again, we're more concerned with submaximal exercise in this particular situation. So lactate threshold will certainly give us a good estimate of submaximal level. Heat will play a role. Biomechanics and bioenergetics certainly play a role in our running economy or economy of movement. It doesn't have to be running. It could be biking or swimming or whatever type of activity you are completing, cross-country skiing, something along those lines. So the economy of movement will play an important role for us there. Again, probably another factor related to genetics would be the type of fibers that you are born with. The two most important factors for us are steady state VO2 or at submaximal level and economy or efficiency of movement. Again, with our exercise bouts that are 3 to 20 minutes, we said Vo2max is the most important factor. So make sure you're remembering what are the most important factors for each of these subcategories. And lastly, here now we got my jam. This is aerobic performance 1 to 4 hours and certainly above and beyond that. Again, very similar to what we saw with 21 to 60 minutes. But now the steady state VO2 is going to be less. Okay, so we said maybe 90% on the previous slide. Maybe in this particular example, we can only work at 75% of our steady state Vo2max. So again, that's going to be probably one of the major components. Again, economy of movement will be super important. The longer you go, the more important it is for us to be efficient at being able to move through that particular mode. Heat, dehydration will play a role. Diet becomes important for us now. Supplement during exercise becomes important for us now. It's important for us to be getting in both fluids and carbohydrates, possibly electrolytes as well. How much did we have stored to start with? That will play a role for us. Lactate threshold, again, related to working at the submaximal level. Again, biomechanics, bioenergetics were related to efficiency and then what we're born with in terms of fibers. Okay, lastly, just a few ideas in terms of possible sites of fatigue. So fatigue is the reason you stop most of the time, particularly in endurance exercise. Fatigue is our limiting factor. So what are some of the reasons or places in which fatigue can occur? In the psyche or your brain. Okay, so you decide you're tired. So psychological fatigue, I'm just done, I'm just worn out. That can be one issue. Motivation certainly can be part of it. The spinal cord, peripheral nerve, neuromuscular transmission. So with neuromuscular transmission, we're concerned with our ability or inability to be able to release acetylcholine into the neuromuscular junction and be able to have transmission of information from the nerve to the muscle occur effectively. So that is greatly affected. Also, our ability to send action potentials might play a role. Our ability to excite the muscle cell itself may be an issue, and calcium release as a result of that may be an issue. Actin and myosin interaction. So the ability of actin and myosin to bind with each other and therefore generate force, which leads us into cross-bridge tension and our ability to do that. And certainly heat, force, and power output. So again, if you can think about the steps involved with muscle contraction, basically every step along the way, there's possibility for failure, and so therefore for fatigue and for that to be a limiting factor. So certainly our greatest possibilities for fatigue are going to be psyche, the brain, the nervous system, something within the muscle itself. And one thing that's not listed here that I think is also super important would be a buildup of waste products. That will also make us feel very fatigued as well as we start to threaten the pH levels. So there you have it. Those are some of the possibilities in terms of fatigue for us at maximal aerobic exercise performance. A couple things. So this is your PowerPoint should be for Wednesday. Let's see what the date is for that. Wednesday, October 5th. And then you have a quiz, an online quiz about this lecture on Friday, October 7th. And I will open up that quiz. That quiz should be open for you from 7 a.m. till 2 p.m. on Friday. So you need to make sure you log in and take that quiz at that time. I would encourage you to look through your notes and, review this information. Hopefully, if you've watched this PowerPoint and you took good notes, you should be set up for success for that quiz. But make sure you kind of go back through and review those. You only get 1 minute per question on that quiz, and I believe I don't remember off the top of my head, I think there's 14 questions. So you have 14 minutes to complete the quiz, and I don't think you'll have enough time to look every answer up. So please make sure you go back through and review some of your notes that you've taken on this PowerPoint. Again, it's very likely that the questions on the quiz are things that I said out loud, things that you needed to write down. So make sure you wrote those things down as you've gone through this PowerPoint. Also, secondly, I posted a PDF of a journal article that I would like you to read that's very good. It's kind of a summary thing for us about aerobic performance. So I want you to read through that. I want you to focus particularly on the Vo2max section and also the efficiency sections. And there are a few quiz questions from that reading. So make sure you read that. It shouldn't take you too long. It's actually a pretty easy read, I thought. So make sure you read that and review this PowerPoint before your quiz on Friday. Have a great day, and I will be back with you soon.